In this course, we've talked a lot about how to create and work with our own objects. Now let's take a quick look at some objects that come built into JavaScript. We'll take a look at 3 common objects that you're likely to use in JavaScript. We'll start with the math object, which comes with lots of static functions for various mathematical operations. Then we'll take a look at the date object, which we can use to create, manipulate, and inspect dates. Finally, we'll take a look at the regex object, which is used for searching and validating strings using regular expressions. The math object is pretty straightforward, but the date and regex objects have some complexity to them. So let's jump in and take a look. The math object is a built-in JavaScript object that has a handful of properties that contain some math constants, plus a whole host of math functions. This Mozilla developer documentation is a great resource for discovering all of the available functions and how they work. We won't go into all of these, but let's just see how to use a couple. All of the properties and functions on the math object are static. That means we don't need to create a new math object before using it. We just use it directly. So let's access one of the math object's constants, pi. We'll display the value of pi like this. So we just call math.pi, and notice that displays the approximate value of pi. And you could use this in mathematical calculations. We can also directly call functions on math, like math.max, for example. Max takes in unlimited numerical arguments and returns the largest of all of them. Or we could call math.round. Round will round a number to the largest whole integer. We're not going to demonstrate all of the other math constants and functions, but just know that you can look at this documentation whenever you need to tap into common math functions like this. The date object is fairly involved, and we'll take a look at some of the more common features here. First, let's create a new date object like this. So we'll just call new date. And creating a date like this without passing in any parameters creates a new date object that represents the current date and time. There are a few constructors, though, that we can use when creating a date. The next one we'll take a look at takes in a number as a date. So we'll pass in 0 here. And this parameter is the number of milliseconds since January 1st, 1970. So if I create a date like this with 0 milliseconds and then display it, then you can see Wednesday, December 31st, 1969 at 1700 hours. Well, this is a little bit confusing because I said it's the number of milliseconds since January 1st, 1970, and this is 5 hours before that, but that's because this is being displayed in Mountain Time, which is the local time zone on my computer. So this actually is January 1st, 1970 Universal Time. And if you look at that time, 1700, and I change this now to 1000 milliseconds, you can see that this is now 1 second after 1700 hours, or 1 second after January 1st, 1970 Universal Time. So you might be wondering, why January 1st, 1970? That is what's commonly called Unix epoch time. But this isn't a very useful way to create dates. So let's move on to a more intuitive constructor, which takes an ISO 8601 string, which looks like this. So now if I save that, you can see we're looking at a date of March 25th, 2050 as represented by this string. This seems really useful, but there's a problem with this constructor in that different browsers may handle that string inconsistently. So by far, the best constructor is not this one, but one that takes in each date and time part as an integer like this. So these parameters in order are year, month, day, hour, minute, second, and millisecond. So if we save this, there we go. We now have April 25th, 2050. Wait, what? April? Why does that say April? I clearly put 3 as the second parameter, which is the month parameter. Well, for some unholy reason, the month parameter is 0 based, and everything else is 1 based. So 0 is January, 1 is February, and 2 is March. And so, of course, 3 is April. Try to embed this in your mind because I can almost guarantee it will trip you up someday. But this is the most useful and accurate way to create dates in JavaScript, is with this constructor. And that covers the different constructors. So now let's take a look at these following functions. Each of these has a corresponding setter also. So I could call date.setMonth and pass in the month. So I'm going to pass in 5 here and save that. And so that changed the month. And if we display this date now, it's important to note that these getters return values that correspond to the time zone of the computer they're running on. But there are also UTC versions of these. And so these return the UTC minutes and day, etc. Another useful thing to be aware of with dates is that you can subtract two dates in order to learn the amount of time between them. So if I create two dates like this, so this first date is going to be April 25th of 2050, and the second date, which is identical except for the milliseconds at the end, 5 milliseconds apart. So if I subtract date 1 from date 2, notice that it returns 5 milliseconds. Of course, if I change the year on date 2 to 2051 and save that, that's about the number of milliseconds in a year. So you can use this to determine how much time has passed between two dates. And these are the most common things you'll do with dates. Again, like the math object, the Mozilla developer documentation is a good place to look for other less common date methods. The JavaScript regular expression object can be used to search strings to see if they contain text that matches a regular expression. Regular expressions are search patterns, and the syntax for all the different possible search patterns are beyond the scope for this course. But let's see how to use the JavaScript regular expressions object. Consider a function like this. This function needs to make sure that a password meets a minimum complexity threshold. We can create a new regular expression like this. So we're going to call new regex and pass in our expression. But we just have one problem. Because this expression is defined inside quotes as a string, this backslash is going to be interpreted as an escape character. So we're going to have to actually escape that backslash by adding a second one here. Okay, so this regular expression will now test to see that a string has lowercase characters, uppercase characters, numbers, and is at least 8 characters long. And now that we have a valid regex object, how do we use this to test strings to see if they're valid passwords? Well, the regex object has a test method that we can call like this. So I can call the test method and pass in the string that I want to test. And let's just go ahead and return the results of this. Now we can go ahead and call this check password complexity function and pass in a password, and this regex test function will return true if the password adheres to the regular expression. If I pass in a string that doesn't match the regular expression, I'll pass in a weak password. And if I save that, you can see it returns false, because there are no uppercase letters or numbers, and it's not at least 8 characters long. So this one will fail too. I have a capital letter and a number, but it's not 8 characters long, so if I save that, that fails also. But this one will return true. Now this weird thing that we had to do with the double backslashes, that's a common problem with treating regexes as strings. And so there's actually a shorthand syntax for creating regular expressions that makes it so that we don't have to deal with this. So I'm going to copy this regular expression here, and then let's create a new regex variable. And the shorthand syntax for regex just uses 2 forward slashes. And then you just put your regular expression between these slashes like this, except we don't want these quotes. And now, because this is not inside quotes, we don't need to escape this backslash. We'll continue working with this new syntax. Before we do though, I just want to mention something for you to keep in mind. This regex function up here takes a second parameter. In a minute, we're going to talk about regex flags, which alter the way a regex searches a string. So for example, I could put an extra parameter in this function call like this. Those are 2 regex flags that we'll touch on in a minute, which means search globally and ignore case. To compare that to the shorthand syntax, those flags will go here. I just wanted to point that out so you could see how this works in both places before I delete this version up here. Okay, so if we save this now, you can see this is still working. Just to prove that, I'll refresh here and you can see it's still returning true. So that's the test function. Next, let's look at one other regex function, the exec function. Like the test function, the exec function is used to search a string, but instead of returning true or false, it returns information about what it found. To demonstrate that, let's delete all of this. And let's imagine a function that is used for searching through application logs for alert messages. Now let's create a regex that looks like this. So this is going to search for the word error followed by a colon. And then we will call the exec function like this. and pass in the log data or the string that we want to search, and we'll return that from our function. And now we'll return some information about what it found. So let's demonstrate this by creating some log data. And notice this has an error followed by a colon in the string. And then let's just call our findAlerts method and pass in the log data. So our regular expression should find this error in our string. Let's take a look at that result. So we'll just display result here and save that. All right, the output here is a little interesting. So let's take a closer look at it. You should understand that the regex function returns an array. And that's what we have here. What was returned was an array with the string error colon. So it's an array with one item in it. But what you might not know is that arrays in JavaScript are really just objects, and you can actually add properties to arrays. So that's what all of this is down here. My display function just breaks these out so it's easier to see them. So notice that the returned array has two additional properties, an index property and an input property. Let's just log each one of these independently to make that a little bit more obvious. So first I'll display the first item in the array, and then I'll display the result.index and result.input. If I save that, there we go. So you can see that I'm accessing result like an array to get the first item, and then I'm also accessing the index and input properties like normal properties. That's an interesting thing to know about JavaScript arrays. Arrays are actually just objects. But you might be asking, if they're just objects, why can I access them like an array with a 0 in brackets like I am here? Well, remember our earlier clip about bracket notation. We're just using bracket notation, and it has a property named 0. Okay, so let's just change this back to display the full result. It returned an array with one element in it, and it is the string that matches our regex. That's the first thing to understand about the exec command, is that it returns an array, and the first element is the string that it found. Any other elements in the array only show up if you're using regex capture groups. More on that in a minute. If you're not using capture groups, the array will always just have one item in it. And then exec also puts these other two properties on the array. The first one, index, indicates where in the array it found the string. Input is just the string that was passed into the exec command. That one's not too helpful. But we were able to get our regex function to find that the string did indeed include an error, and we know that the error starts at position 8 in the input string. But this leaves a few questions. Number one, why does the array return the exact string that we searched for in the regex? Our regex is error colon, and that's what's returned, and that doesn't seem too helpful. Number two, what if there was more than one error in the string? How would we find them all? And number three, what else can appear in that array? Well, let's take these one at a time. So first, why is it returning the exact text of our regex in the array? Let's consider a more complex regex. So let's move this back over, and let's add a little bit more info to our error string here. So let's say after the word error, in parentheses, it indicates the severity of the error. And if I save that now, our regex exec function returns nothing. So let's fix the regular expression to find all errors regardless of the error level. So we'll come up here and change our regex to this. That will find the string error, followed by any characters, and then followed by a colon. The question mark just makes sure our regex isn't too greedy. We won't get into that in this course, but now if we save that, the value returned in the array is not the same as our regex anymore, but it is all of the text that was found using our regex. That makes this more useful. Okay, now for the next question. What if there were multiple errors in this string? Let's add one and see what happens. So here at the end of this string, we'll add a second error. And now if we save this, you can see nothing changed in our output, except for the input property, which we've already established is not very helpful. You may have expected to see multiple results returned in the array. I know I certainly did when I was first learning about regex exec. But here's the interesting thing. The regex object is actually stateful. It keeps track of every time we call the exec function. So up here in our function, let's call it multiple times. So I'll call it once here. So I'm going to call exec and pass in the log data. And then let's go ahead and display that. And then for now, instead of returning this, let's just display it too. And then just to make this a little more legible when we output it, let's display a long line between the two of these. Okay, let's see what that did for us. Well, dang, it's displaying the first error both times. This is where flags come in. By default, each time we call exec, it's going to find the first match and stop trying. To have it keep searching past the first one, we need to give it the global flag. So over here in our code, in our regular expression, let's just add a G at the end here. And then let's save that again. Okay, great. Now the first time we call exec, it finds the first one, and the second time, it finds the next one. So the regex object uses internal state to track where it is in searching the string for future calls. Now there is one thing to be aware of with regards to that state. What if we changed our function to just return the result again like this? And then down here, what if we call find alerts multiple times? So I'll just call it once with log data, and then we'll display a line. And then we'll call find alerts again. And then if we save this, notice that we're back to finding the first error twice again. Each time we call find alerts, we create a new regex here. And every time we create that, it resets the state. So just remember that when working with exec, you want to create the regex once and then call exec multiple times. Okay, now to our last question. Why does exec return an array if there's only ever one item in it? Well, that's for regex capture groups. So let's put this back how we had it. So we're going to delete these calls, and we'll just call this here without displaying it. And then up here again, we're just going to call exec multiple times. But now let's add a couple of capture groups to our regex. Capture groups allow you to capture and return data from within the input string. So let's add two capture groups. One to capture the level of the error, and one to capture the error message. So the parentheses here is what creates the capture group. The first one is going to capture everything after the word error, and the second one is going to capture everything after the colon. And then we want it to capture everything up to the semicolon, which is where the next error occurs. And if I save that, then you can see it spit out a lot of stuff, but it's a little bit messy. To make this a little easier to read, I created a display regex array method that breaks down the display of that array a little bit. So let's use that here instead of display. And let's save that. Okay, that's a little easier to see. The first element in the array is still what the regular expression matched, but the second element in the array is our first capture group. It captured that this is a high-level error. And the second element shows the error message. That's pretty handy. There's just one last thing to demonstrate here. The way I've written the find alerts method will only ever find and display two errors. If I was to add another error to the string, it wouldn't get displayed because we're only calling exec twice. So let's make this method a little more useful. We'll just keep calling exec until we don't find any more errors. So let's delete this. And right here, we'll call regex exec and pass in log data and set result to that. And then we'll start a while loop. And let's indent this. And then each time through this loop, we'll display the current error level and message, which are the second and third elements of the result array. And then we'll add a little divider here. And let's indent those appropriately too. And then at the bottom of the loop, we'll just call exec again and set result to what's returned. So this while loop will keep looping until exec returns null. So let's save that. And there we go. We can see that it kept looping and it printed each error. And if we add another error to the log data here, so this is how you can use a while loop to keep looping over the exec function until it stops finding results. And that captures the major things that you need to know about the regex object. There's a lot to it, so you might want to come back and review this clip if you didn't quite catch it all. In this module, we learned about the math object and how it encapsulates a host of math constants, like math.py for the value of pi, and other constants. The Mozilla developer documentation is a great place to look for more info on the various math functions available. We also took a look at the date object. Key takeaways are that you can create a new date that represents the current date like this. We also learned that there are a few constructors for creating dates with specific dates and time. We then discovered the various methods to inspect the different date and time parts of a date. And don't forget that the number returned by getMonth is zero-based. That can trip you up if you forget. Also remember that these functions use the local time zone and that there are UTC versions that return values in universal time. Finally, we looked at the regex object. Remember that there are two different ways to create a regular expression, using the new keyword or using the regex shorthand. And then you can use the test function, which will return a Boolean indicating whether the string contains text that matches the regular expression. We also looked at the exec command to search a string. And remember that the regex object is stateful, meaning that you can call exec multiple times and keep finding multiple matches in the string. And with that summary, this wraps up this module and course. In this course, we also learned how to create objects using object literals, constructor functions, and classes, how to modify property descriptors with object-defined property, and how to create property getters and setters. We took a deep look into what prototypes are and how they affect inheritance behind the scenes, and how to create inheritance chains with constructor functions and with classes. Thanks for joining me, and I hope you've enjoyed this course on JavaScript objects, prototypes, and classes.